So in the previous video, we took a look at the integral of e to the x and the integral of 1 over x. And so now we're going to continue to expand our repertoire and take a look at the integral of sine of x and the integral of cosine of x, the two most basic trig functions. And so here I've written out the derivatives of both of these functions. So here we have the derivative with respect to x of sine of x, which we've previously established is cosine of x. And using this piece of information, we can immediately determine that the indefinite integral of cosine of x dx is just sine of x plus c, right? That makes sense, because if the derivative of sine of x is cosine of x, then the integral of cosine of x will be sine of x, and then since it's an indefinite integral, we're just going to have to add that constant of integration. And then with respect to cosine of x, we know that the derivative of cosine of x with respect to x is just equal to negative sine of x. And so with that in mind, we can then say that the integral, or the indefinite integral, of negative sine of x dx is equal to cosine of x plus c, right? Again, because the derivative of cosine of x is negative sine, then the integral of negative sine will be cosine, and then, of course, we have the plus c. And so before we delve into a couple of examples, let's just quickly discuss a property that I hadn't previously mentioned. This kind of just comes from the kind of scalar or constant property of integrals. It tells us that if we're integrating any arbitrary function f of x dx, then we can essentially multiply f by some constant a, by some non-zero real number a, and we essentially just have to multiply by the reciprocal outside of the integral, if that makes sense. So essentially, we can have the integral of f of x dx is just equal to 1 over a times the integral of a times f of x dx, where a is a member of R star, which just means that it's a non-zero real number. And this makes sense, right? Because if we were to take this 1 over a and bring it into the integral, then it would actually cancel out with the a multiplying by f of x, right? And so we would just end up with the integral of f of x. And this is very much analogous to when you're just multiplying and dividing by the same quantity. It really doesn't impact the original value of the function or whatever you're multiplying by. Because you're kind of just multiplying and dividing by the same quantity, they'll cancel out, and so it doesn't really change the value. And so with that in mind, let's go ahead and delve into a couple of examples now using the integral of sine of x and cosine of x. So here we have the indefinite integral of 40 cosine of x. And so we can take the 40 out if we would like, and we would end up with 40 times the integral of cosine of x dx, the indefinite integral of cosine of x dx. And we've already established previously that the indefinite integral of cosine of x is just going to be sine of x, and then we have the plus c. So we'll multiply by 40 sine of x, and then we have the plus c. And so this right over here would be our final answer. And then next up, we have the definite integral from 0 to pi over 2 of negative 1/2 sine of x dx. And so we can keep the 1/2 in if we would like, or we can take it out. It doesn't really matter. But all that matters is we have to notice this negative sign over here and the sine of x. So we're essentially taking some constant times negative sine of x, the integral of some constant times negative sine of x. And so we know that's just going to be 1/2 cosine of x, right? And we're evaluating that from pi over 2 to 0. And this makes sense. If you take the derivative of 1/2 cosine of x, you'll end up with negative 1/2 sine of x. And so now let's just go ahead and evaluate it at these two bounds of integration. So we get 1/2 cosine of pi over 2 minus 1/2 cosine of 0. Cosine of pi over 2 is 0, so this entire term disappears, and cosine of 0 is 1. And so this entire thing is just equal to negative 1/2, and that would be our final answer right over there. And then next up, we're taking the indefinite integral of 4 sine of x dx. And so now we don't actually have a negative sign, but we're going to use the property that we previously established, that sort of constant property, in order to manipulate this integral in a way that allows us to actually see that there is, in fact, a negative sign over here. And so let's go ahead and do that. So we have the integral of 4 sine of x dx. What we can do is we can multiply by negative 1, and then we can also divide by negative 1 in the integral, and then we'd end up with something like this, essentially. But we know that when we're dividing by negative 1, it's just the same thing as multiplying by negative 1. So we ultimately end up with the negative indefinite integral of negative 4 sine of x dx, right? And these two negative signs would cancel out if you were to bring one of them out or one of them in. And then over here, we now notice that we have a negative sine of x and we have a 4 as our scalar. And so this just becomes negative, and then we know that this will ultimately become 4 cosine of x. And then we have that plus c over there. It doesn't really get impacted by any scalars, the plus c. We always just have to add it. And if you were to actually take the derivative of this function, you would notice that you would have negative 4 times the derivative of cosine of x, which would be negative sine of x, and then that would become 4 sine of x. And so that would be our final answer right over there, and that's kind of how we can determine it in a bit of a more formal way. But honestly, when you start getting used to actually integrating, then it's very easy to kind of just look at this and do it in your head without having to write out all of these different steps. And so finally here we have the integral from 0 to 3 pi over 2 of negative 2 cosine of x dx. And so again, we can take the negative sign out if we would like, and we would get the integral from 0 to 3 pi over 2 of 2 cosine of x dx, right? And we know that the integral of 2 cosine of x is just going to be 2 sine of x. And so this becomes negative, and then we have 2 sine of x, right? And we're evaluating this from 3 pi over 2 to 0. And again, you can verify, you can take the derivative of this, and you'd end up with negative 2 cosine of x. And so then we just evaluate this at the two endpoints. We get negative 2 sine of 3 pi over 2 minus negative 2 sine of 0. Sine of 0 is 0, so this all disappears. Sine of 3 pi over 2 is negative 1, and so this ultimately becomes 2. And so that's our final answer. So I hope this helps. I hope this isn't really too confusing. In the next video, we're going to kind of look at a few more different trig functions and their integrals.